Howdy, welcome to my final presentation for COSC 461, Building Information Modeling Systems. My name is Sean O'Keefe and I will be your guide. Let's check it out. The project name is Prairie A&M University Agriculture and Business Multipurpose Classroom Building, and it is being built for Prairie A&M University. The architect for the project is Overland Partners. The cost of the project is $37,800,000, and the contract type is guaranteed maximum price. The project is located in Prairie View, Texas. The total square footage of the building will be 90,000 square feet. Let's take a closer look at what will be included in the building.
The fourth floor will contain several faculty offices, faculty lounge areas, several conference rooms, and labs. The third floor will consist of faculty offices, a conference room, and lab areas. The second floor will contain several classrooms, a computer lab, a recording studio, group study rooms for students, student lounge area, and the main mechanical rooms. The first floor will hold 8 classrooms, a computer lab, the business center, conference room, 2 monumental staircases, and the electrical yard.
Now that we have an understanding of the project, I would like to discuss the BIM tools that will be utilized. BIM tools reduce rework, improve productivity, and reduce conflicts and changes during construction. Let's take a closer look at a couple of these tools.
The Navisworks 4D simulation tool will be used to find the optimal installation sequence. It permits the construction team to better analyze the construction schedule with respect to time, cost, and safety. It also improves the communication of the design and schedule to all project participants. The Navisworks clash detection tool allows the project team to coordinate and discover issues between building components prior to them being installed in the field, saving the owner both time and money.
I hope that you enjoyed learning about the BIM tools discussed. We will now take a more in-depth view of the project site and construction sequence.
Construction fencing, shown in red, will surround the construction areas. Gates will be located at the north and east sides of the construction site. There will be a guard at the north gate during construction hours to prevent unauthorized visitors from entering the site. The east gate will remain closed with exceptions for deliveries or other access needs. Secondary laydown area, shown in green, will be located off-site to the west down Ann Preston Street and will be used for contractor parking. The primary laydown area for the project, shown in orange, will be located at the northeast corner of the site. The building, shown in blue, will be centrally located on the site. The crane, shown in yellow, will be positioned between the building and the laydown area. This will increase efficiency since it will decrease the number of times that materials will need to be moved around the site. Pedestrian pathway is shown in purple. Existing sidewalks will remain unobstructed for navigation around the site. Shown is the route that will be taken by both contractors and delivery drivers. This route was chosen to avoid the main entrance and central portion of the campus in order to diminish disturbance to ongoing university activities. Project mobilization will begin with the delivery of the porta potties, followed by the installation of the construction fence. Next, job site trailers will be brought, followed by the dumpsters and connexes. After project mobilization, site work will begin. After the building pad has been prepared, substructure work will begin with the installation of the auger cast piles. Piles will be cast in place using a hollow stem auger with continuous flights. There are a total of 85 auger cast piles that will support the building. Next, the pier caps will be installed. The elevator pit will then be poured. During this time, underground MEP is also taking place. Following inspections, the first floor grade beams and slab will be poured simultaneously. The crane will be erected at this time to assist in the remaining substructure construction. The first floor columns and elevator shaft wall are now being poured. This process will repeat for the second floor, third floor, fourth floor, roof deck. Temporary shoring will be placed between each level until the concrete has had time to cure. Once the concrete structure is complete, the steel will be erected. The steel erectors will also install the stairs and pipe railings. Mechanical equipment will be placed on the building, including the air handling unit, chiller, and boiler. Penthouses will be installed, followed by the main roof. Brick and stone masonry walls will then be set from levels 1 to 4. Zinc siding and roofs will then be put on the building, followed by the exterior windows. The mullions for the curtain wall system will then be installed, followed by the remaining roofs. Next, the glazing for the curtain wall system will be placed, followed by the exterior doors. Finally, the soffits will be installed to complete the building drying process. Clocks will be placed prior to the crane being taken down. Interior construction will start with the fourth floor to avoid work that is in place from being disturbed. The interior's construction process on each floor will begin with the walls being framed. Next, MEP rough-in will take place, followed by the ceilings. Afterwards, interior glazing will be installed, followed by the MEP vinyl and trim out. To complete each floor, doors will be installed. After MEP rough-in on the first floor, the passenger and freight elevators will be installed. A substantial completion date for the project is March 26, 2014. In preparation for this date, the superintendent will compile a punch list for subcontractors to complete. He will also walk the project with local inspectors to receive the building final green tag. I would like to thank our sponsors, the architect, Overland Partners, Prairie View A&M University, the Texas A&M Department of Construction Science, and Dr. Julian Kane. Thanks and gig 'em.